Applications and theory. Boilers are used throughout the world to provide steam for heat, process, and power. Virtually every daily activity is in some way affected by boilers. Boilers and their related equipment are very costly and are often considered the most important piece of equipment in a facility. Boiler operators are responsible for operating the plant for maximum safety and efficiency. Boiler applications in industry. Heat for buildings, industrial processes, and power generation rely on boilers. Steam is widely used in the paper, textile, food processing, and petroleum industries. Cogeneration plants generate steam and electricity at the same time. Waste heat boilers burn refuse and industrial waste to generate steam and electricity. History of boilers. Steam and boilers were used as far back as 120 BC. Hero of Alexandria produced the first steam turbine by heating water in a closed vessel. Steam was directed through vents, which caused the vessel to rotate. Further development of steam turbines was slowed by the lack of materials strong enough to withstand stresses caused by high speeds and temperature changes. Before steam, industrial processes used horses and water wheels as a source of power. The greatest impact of the use of steam power occurred during the Industrial Revolution of the 1700s and early 1800s. During this era, inventions using steam power greatly affected the standard of living. The steam engine provided the power required by the new industrial machinery. Early steam engine designs wasted much heat and were not reliable enough for industrial use. In 1736, James Watt of Scotland was credited for the development of the reciprocating steam engine. This new steam engine proved reliable and operated very efficiently by producing more power with less steam. Larger, more efficient boilers were developed to generate the steam used in the operation of steam engines. In the late 19th century, new metals which could withstand high operating temperatures advanced the development of the steam turbine. Today, steam turbines have, in most instances, replaced steam engines. Boiler operation theory. A steam boiler consists of a closed container, water, and heat. The closed container holds the water, transfers the heat to the water to make steam, and collects the steam that is produced. Heat is most commonly generated by the combustion of a fuel. To produce steam, heat is applied under the container. Steam is produced as the water is heated to 212 degrees Fahrenheit, and the water boils and turns from a liquid state to a gaseous state. When a lid is placed on the container becomes a pressure vessel. A pipe in the lid can be used to direct steam to where it is needed. Boilers are designed to use heat efficiently to minimize the cost of producing steam. Heating, or thermal efficiency, is accomplished by increasing the heating surface. The heating surface is the part of the boiler where water is on one side and heat on the other. Increasing the heating surface increases the size of the combustion chamber. This allows the fuel to burn more efficiently as the fuel mixes with a greater quantity of air. As boiler designs evolved over the years, greater thermal efficiency was achieved. All steam boilers operate using 4 systems: the feedwater system, the steam system, the fuel system, and the draft system. Each system must be controlled for maximum safety and efficiency. The feedwater system supplies water to the boiler. Feedwater is treated and regulated automatically to meet the demand for steam. Valves installed in the lines permit access for maintenance and repair. The steam system collects and controls the steam produced in the boiler. Steam is directed through piping to the point of use. Throughout the steam system, steam pressure is regulated with valves and checked using steam pressure gauges. The steam and feedwater systems share some components. The fuel system includes all equipment used to provide fuel to generate the necessary heat. The equipment required in the fuel system depends on the type of fuel used. All fuels are combustible and dangerous if necessary safety precautions are not followed. Fuels commonly used are fossil fuels such as fuel oil, natural gas, and coal. Other methods of generating heat include electricity and nuclear fission. In a fuel oil-fired plant, fuel oil leaves the tank through the suction line and duplex strainer and then goes to the fuel oil pump. The fuel oil is forced from the pump through the discharge line. From the discharge line, some fuel oil is burned and some returns to the tank through a regulating valve. In a natural gas-fired plant, gas is supplied to the plant at a set pressure. This pressure varies depending on the source, whether a city gas supply line or gas plant. Gas systems are low pressure or high pressure.
In a low-pressure gas system, city gas pressure is reduced to 3 to 5 inches through a regulator.
From the regulator, gas is drawn into the burner and mixed with air supplied by a blower. This mixture is directed to the burner, where it is ignited by the pilot light. In a high-pressure gas system, gas passes through the regulator and pressure is reduced to the proper pressure for the burner. A solenoid valve opens at the right time in the cycle to admit gas to the butterfly valve. The butterfly valve controls the firing rate through the gas linkage. Some boilers have combination burners, which can burn gas, fuel oil, or a combination of both gas and fuel oil. Coal-fired boilers use mechanical feeders or stokers to feed coal to the burner at a consistent rate. For example, in a chain grate stoker, coal is fed through the hopper and regulated before passing under the ignition arch. The coal continues on a conveyor which carries the ignited coal slowly under the heating surface. Ash, slag, and unburned parts or clinkers are discharged at the other side of the conveyor. The draft system regulates the flow of air to and from the burner. For fuel to burn efficiently, the proper amount of oxygen must be provided. Air must also be provided to direct the flow of air through the furnace to discharge the gases of combustion out of the furnace to the breeching. Forced draft uses a fan to force air through the furnace. Induced draft uses a fan to draw air through the furnace. Combination or balanced draft uses forced and induced draft fans. From the breeching, gases of combustion enter the chimney and are released to the atmosphere. Steam to water cycle. In a steam heating system, steam leaves the main steam line and enters the main header. From the main header, piping directs steam to branch lines. Branch lines feed steam through a riser to the steam heating equipment. At the heating equipment, heat is transferred to the building space. As the steam releases heat to the building space and cools, it turns back to water or condensate. The condensate is separated from the steam by a steam trap. The steam trap allows condensate to pass through, but not steam. The condensate passes through the condensate return line and is collected and directed back to the boiler to repeat the steam to water process. Boiler operation safety. Boiler operation is a serious occupation requiring trained operators. Licensed boiler operators have passed a licensing examination. A boiler operator's license documents that the holder is qualified to safely operate and maintain steam boilers and related equipment. Approximately 1/3 of the states in the United States have licensing laws regulating the requirements for certification of boiler operators. States that do not issue a state license may have jurisdictions within the state which establish licensing requirements. For example, Pennsylvania does not have a state licensing requirement, but the City of Philadelphia does. Information about boiler operator licensing can be obtained from the appropriate city, county, or state authorities. A licensing jurisdiction will often have specific grades of licensing examinations for different sizes of boilers and related equipment. Some jurisdictions require experience in the field prior to taking a licensing examination. A boiler operator's licensing examination typically consists of a variety of true-false, multiple choice, completion, and essay questions. These questions are similar to the questions in the Boiler Operation Videotape Workbook accompanying this video. Some examinations may require the demonstration of practical boiler operation skills, such as blowing down a gauge glass. Boiler operator clothing. Boiler operators must wear the proper protective clothing and safety equipment. A shirt and pants made of durable material like denim are best suited. When performing some maintenance tasks, coveralls provide protection from possible contact with hot equipment or sharp objects. Some plants require fire-resistant coveralls for additional protection to the boiler operator. Loose jewelry should be removed or secured. Safety shoes with durable, oil-resistant soles are recommended. Steel toe shoes provide protection from falling objects. A safety helmet should be worn in areas where overhead danger is possible. Proper eye protection should be worn when working with feedwater chemicals, inspecting the fire in the furnace, or other potentially hazardous activities. Ear protection may be required to prevent injury from noise. Plant procedures will dictate specific boiler operator protective clothing and accessories. Fire safety. The boiler room contains combustibles which require special handling and treatment. Prevention is the best strategy against potential fire hazards. The boiler operator must take the responsibility in preventing conditions which could result in a fire. This includes proper storage of oily rags, proper use and storage of solvents, and immediate cleanup of combustible spills. In the event of a fire, the boiler operator must act quickly to minimize injury and damage. To start and sustain a fire, fuel, heat, and oxygen are required. A fire will go out when any one of the three is taken away. Fires are classified by the combustible material as Class A, Class B, Class C, and Class D fires. Class A fires are fires that burn wood, paper, textiles, and other materials containing carbon. Class B are fires that burn oil, gas, grease, paint, or other liquids that convert into gas when heated. Class C are electrical, motor, or transformer fires. Class D fires are not as common as classes A, B, and C. Class D fires are caused by combustible metals such as zirconium, titanium, magnesium, sodium, and potassium. Fire extinguishers must be routinely checked for the proper charge according to plant procedures. Additional fire extinguishing equipment such as water hoses and sand buckets must also be routinely checked. Emergency procedures. Emergency procedures for the plant detail the exact actions to be taken in the event of a plant emergency. The chief engineer is responsible for establishing specific plant emergency procedures. The boiler operator must be thoroughly familiar with these procedures. The three most common conditions which could lead to an emergency are high or low water conditions and flame failure. Improper actions taken during these conditions could cause the boiler or furnace to explode. In any plant emergency, the proper authorities must be notified immediately. Reporting injuries. Accidents which occur in the plant must be reported regardless of their nature. Accident reports commonly include the name of the injured person, date, time, place of the accident, the immediate supervisor, and the circumstances surrounding the accident. Accident report forms are required for insurance claims and become a permanent part of plant operation records. Review. Boilers are used in industry to produce steam for heat, industrial processes, and the generation of electricity. A steam boiler consists of three elements: a closed container, water, and heat. All boilers operate using four systems: the feed water system, the steam system, the fuel system, and the draft system. Licensed boiler operators have passed a licensing examination and are qualified to operate and maintain steam boilers and related equipment. Fuel, heat, and oxygen are required to start and maintain a fire. Fires are classified by the combustible material as Class A, Class B, Class C, and Class D fires. Emergency procedures detail the exact actions to be taken in the event of an emergency. This videotape depicts boiler operation procedures commonly practiced in industry. Boiler operation procedures vary from plant to plant. For maximum safety, always refer to specific plant procedures and applicable federal, state, and local regulations.